Hello again, 99ers, and welcome to anyone else who's curious about TI computers and just wandered on in. If you just got here, you might be 40 years late to the party, but good news is, there's never been a better time than now to write software on a TI-99. And one of the main reasons there's never been a better time than now is the XB Game Developers package, and the basic compiler it comes with, which is what I'll be diving into today. Lately, I've looked at all sorts of ways we've seen BASIC on the TI-99 taken to crazy new heights, with a better, more powerful graphical toolset, and new features that classic XB just couldn't give us at all. But nothing's transformed the use of BASIC on the TI-99 lately more than the Game Developers package, because that gives you support routines for features like smooth scrolling that, well, you don't see a lot on the TI-99 even in assembly. And when you're done figuring out how you want to use those features, it lets you compile your program for a massive speed boost. It won't take long at all to show you how to compile code with the XB Game Developer package, since that step is really dead simple. But that kind of figures. It's everything that happens before compiling that's the tricky part. Compiling is going to make your program run a lot faster once you've already gotten it where it needs to go. But before that, you need to design something that takes advantage of what the package has to offer. And your main tool for doing that is XB256. XB256 is the BASIC built into the developer package, and like the rest of the package, it runs out a regular XB. No special cart required. If you want all the features of the package, you'll need a disk solution and the 32K upgrade. But those are must-have TI upgrades just about anywhere else at all. So probably if you're here, you've already got that covered. And while XB256 is your main tool for building compiled BASIC programs, it's also just a really nice full-featured BASIC in its own right. So you can write and run and bug fix and test your programs from BASIC's immediate mode, same as you would in plain old XB. And then if you want a huge speed boost, just compile from the menu. And if your program runs fast enough as it is, well, sometimes you might just not worry about compiling at all. XB256 can do some pretty impressive stuff running straight from the interpreter. And it can be nice to have your BASIC code always at hand to tweak and poke away at any time you please. Either way though, XB256 gives you a powerful new BASIC to write games in, or any other kind of demanding TI-99 software at all. Whether you run interpreted or compiled in the end, it gives you some pretty impressive new toys to play with. And those include a collection of powerful new scrolling routines. Something you'll hear pretty often about the 9918 graphics chip in the TI-99 is it can't do hardware scrolling. So, if you want to do any kind of scrolling, well, you'll have to do it in software. Still, we did get plenty of scrolling in the end, and Parsec gave us smooth scrolling just about right off the bat in '82. So we always knew that you could do quite a bit on the TI-99 hardware. But Parsec was a masterpiece from one of the brightest TI minds of the system's heyday, written in assembly, and our options in BASIC are a bit more limited. People still did try to make scrolling happen in BASIC occasionally, like in Rescue here, a Defender clone that does a pretty impressive job under the circumstances, delivering horizontal scrolling gameplay as best it can. But of course, the result is slow. Most of the time, the one-tile vertical scroll the print command gives you is the only kind of scrolling you'll see in BASIC, and it just isn't much to work with. Though 100 skiing and racing games did their best with it back in the day. Regardless, we can do a whole lot better now, because with XB256 you've got powerful options for scrolling backgrounds in BASIC on a TI-99. Now in my recent look at XBGEM, I showed how T40XB can do some really useful window scrolls. Then I showed you how TML Graphic Adventure can even scroll a window while displaying bitmap graphics too. But as great as those are, they're focused on scrolling window text upward, which is great if you're writing an adventure, but not all that useful just about anywhere else. What I'd like to have in an action game is the option to scroll any kind of graphics of any size in any direction, anywhere on the screen. And that's what XB256 lets you do. So that lets me do interesting things like scroll an RPG overworld as my character moves around a map. So everything outside the window stays where it is and only the contents of the window get scrolled. I get a little fancy there by putting an 8-pixel wide sprite mask made up of 32-pixel sprites on all sides of the window, so you never actually see tiles written and overwritten and the lines being scrolled. But however fancy you want to get about it, this option to use a window scroll to move around a tile map is a great option to have in BASIC, especially for an RPG. Though it's definitely not the only way you can use a window in this kind of game, because using a window in exactly the opposite way is pretty handy too. In this demo, instead of using windows to move a world around a character, I'm using windows to move characters inside a world. Using windows means I can move any given tiles in any direction I like, so an entire army, or just a part of it, can go on the march. Plus, using tiles instead of sprites for the characters has a couple advantages. I can have more than 4 on a scan line, and multi-tile characters can use more than one color. So when it comes to that chunky one-tile scroll the 9918 is famous for, well, XB256 gives you some great tools. There's just a lot you can do with a one-tile scroll. Still, folks looking for assembly superpowers from their compiled BASIC probably want to look beyond the chunky scroll, if at all possible. So, it's a good thing XB256 also makes smooth scrolling an option. In Vanilla XB, Rescue probably does represent just about the best horizontal scroll you can do. And the upshot of that probably is you just shouldn't be trying to do a horizontal scroll in Vanilla XB. Especially because if you flip things vertically, sprites are a way better tool for scrolling a background in XB. It's pretty much the whole point of a sprite that it ought to be able to move smoothly along a trajectory, independent of any other layers. So, some XB games like Force 1 here are clever about that, and use sprites as a background graphic to create the illusion of a full-screen smooth scroll. Supercar is another XB game that uses sprites this way, with the moving graphics on the sideline of the track being sprites in motion, making it look like you're moving across the countryside while your car's sprite in the background graphics stands still. But like I said, this only really works vertically. With only 4 sprites per scanline, you can't do a parsec-style horizontal scroll where a whole screen's worth of tiles are scrolling in a row. For that, we need something else, and XB256 delivers it in a couple different ways. 2 kinds of smooth scrolling routine are on offer in XB256, and the first one lets you scroll a set of patterns in a circle. So on a screen like this, where the ground is made up of 2 alternating patterns, scrolling the pattern data in a circle scrolls the whole of the ground. And naturally, we can still get fancy by adding some sprites, to give even more of a sense of motion. But because we're not actually scrolling the background, just the patterns for certain tiles, any static interface elements stay put. And we can get even fancier. We're not limited to scrolling just one set of patterns. We could scroll multiple sets of different lengths like I'm doing here, and get ourselves a parallax scroll. Then, add some sprites, and again, it helps to liven up the scene a bit. But this is maybe where I'm compelled to admit that an interpreted BASIC is having just a bit of trouble keeping up with everything I'm throwing at it. The scroll is getting a bit jerky at this point, so let's compile. I'll add in one more scroll for 3 in total, since, well, now that we're compiling, we can pretty much kiss goodbye any performance worries we had there. And we'll start the compiling process by saving our basic file in merge format. Next step is to go back to the menu, which I'll do by running the autoloader, and I'll select the compiler at the menu. Then at this point, most of the time you're going to be fine literally just hitting enter at each prompt until you're done. Default values should be fine. The assembler is going to assemble our object file, and if there are no errors, our next enter press is going to take us to the loader. That's going to spit out 2 important files. One's an EA5 loader for loading from editor assembler, and another's an extended basic loader. And with all that finished, I can get a run prompt and run my program. Now that probably seemed like a lot. But to be perfectly clear, all I did was 1. Save my program in merge format, then 2. Launch the main menu and select the compiler. After that, I pressed the enter key until my compiled program was ready to run. It even typed the word run for me. So, compiling an XB256 program might look complicated, but it is dead easy. And what we get when we hit run is a noticeably faster, smoother version of the program, even though it's now doing 3 scrolls instead of 2. And compiling can only do so much here. The XB256 scrolling routine per se was already in machine code, so there's no speeding up the routine itself. It's just no longer being held up by all the basic infrastructure that was calling it. So that's pretty cool, but it's not the only kind of scroll we can do in XB256, because another more niche but still very cool feature is vertical text scrolling. This is a special kind of per pixel scroll because it's scrolling arbitrary text. It's not just rotating a couple adjacent patterns like our circular scroll did. It's scrolling dozens of unique patterns. And that uses most of our VDP pattern memory. Only a little bit of that's left for things like our title banner there. But on a title screen, you probably don't need a ton of free patterns. So I think that's where this effect belongs. It's definitely a cool effect to have on the title screen of any game developed under XB256. And if you do find yourself running out of patterns, well, there's always the option of using sprites as static graphics. 28 double-sized sprites can just about fill a screen on their own. And the good news is, XB256 does its part to make XB sprites even more useful. In XB256, you've got 2 screen modes to work with and switch between. Screen 1 is exactly like Extended Basic's normal screen mode, in that you got 112 tile patterns, 28 sprites, and 14 tile palettes. But Screen 2 has 256 patterns with 32 palettes, which means your backgrounds can manage a fair bit more detail than they could in standard XB. So in a screen like this one, I can freely use tons of patterns on little terrain details and not really have to worry about running out of patterns. This one uses 242 in the end, so it's getting close, but it still manages to fit in under the 256. But sprites get a boost here too, since sprites on Screen 2 use patterns from Screen 1's pattern table. So, despite nearly using up all my patterns on background tiles here, I've got 112 more patterns to add sprites with if I need them. Enough for 28 double-sized sprites if that were somehow necessary. So, way more patterns just for sprites is a pretty big bonus. But the other main sprite feature XB256 brings to the table is a little less obvious, and that is the sprite early clock. Looking at any classic XB game, something you might notice is how the right side of the screen sees sprites fade in and out a pixel at a time, which is nice. The catch is, the opposite is not true. At the left side, you're going to see them just pop in all at once. Reason being, they're positioned based on their upper left pixel, and when that's at the far right, they're nearly off screen, but when that's at the far left, they're entirely on screen. The sprite early clock is the answer to that, and it lets you put sprites 32 pixels further to the left, so if you need them to, they can enter the screen 1 pixel column at a time on the left, just like they could on the right. Alright, so that's a lot to work with graphically. But I haven't even mentioned sound here yet, and I do really like a TI-99 game with good music. So we ought to talk about what XBGDP does to help a TI-99 game have a great soundtrack. Usually, the main problem with writing soundtracks into your basic games is just keeping the music going while doing whatever else your program's gotta do. Basic has a one-track mind. It just can't do two things at once. So the only way to give a basic game a real soundtrack is to, well, work it into your main game loop and try to keep the timing of that consistent. Which isn't easy. So even the best XB games usually don't have music. As with so much else though, XB256 has a solution here. It gives you the tools to compile the sound list from the call sound statements you'd normally use in BASIC, and that compiled sound list can be played uninterrupted during gameplay, just like you'd see in the best assembly games out there. In the extended BASIC Sphere games, Billy Ball to the Rescue is one of the best out there if you ask me. So I was interested to see if it would benefit from a soundtrack. And with a compiled soundtrack in hand, adding it to the game is as simple as adding 3 commands to the start of the program. One to load the compiled code, another to load the sound list into VDP, and a third to play it. Not bad at all. The game development package has some pretty rich options for managing multiple sound lists and compiling your music. But for most folks, I figure the main thing is just having a simple, easy way to turn your list of call sound commands into compiled music that plays in the background while your program runs. Like almost everything else on the TI-99, this is another feature that basically comes down to loading data to VDP efficiently and managing your VDP memory map effectively. So, as far as VDP goes, I think I'd better talk about a trump card XB256 gives you that gives you unlimited access to that all-important VDP RAM. Extended Basic added a much-needed load command to TI Basic, and that does let you poke data into RAM. But since the CPU can't access VDP RAM directly, you can't actually poke anything into VDP, and this poses a bit of a problem, since VDP is where almost everything happens on the TI-99. Now, the mini memory and editor assembler carts did add pokev and peekv commands in addition to the load command, and those do let you poke data into VDP directly, so there is that option. But if you're willing to give up extended basic for the sake of a pokev command, I question your priorities. So you probably aren't. Well, XB256 has an extended basic option with a whole lot more to offer in the form of the vread and vrite commands. And they're better than plain old poking in a few key ways, but mainly in that they work with strings. So you can write a whole string to an address range in VDP with vrite, or read an address range into a string with vread. And what can you do with that? Well, kind of almost anything. But just for an arbitrary example, palette data is a 32-byte range in standard mode, so, well, if we periodically generate a random 32-byte string and dump it into a range where XB256 puts the color table, we can randomize the entire 64-color palette, on the fly, in one command. Pointless. Utterly pointless. But neat. So the Extended Basic Game Developers package gives you a really easy way to compile your plain old Extended Basic programs to an EA5 or XB Autorun program. And that'll execute way faster than any regular Extended Basic program ever could. Which is amazing. But it'd be kind of boring and a little pointless if all it did was let you do the same things XB always let you do, just a whole lot faster than you actually need to do them. The best assembly games aren't just faster, they're doing some key things XP simply can't do, like smooth scrolling an entire background, or playing background music. So XP256 giving you new ways to access those features is a huge part of what makes it a powerful development tool. Because now, your basic program can have easy to create, uninterrupted background music. And it can scroll an area of the screen while leaving your interface where it is. Or it can selectively move blocks of tiles across the screen. And it can even do a per pixel scroll. So I sure do hope to hear you folks are working on your own projects with the XB Game Developer Package over the next while. I'm certainly having fun messing around with it for my part, as you can see here. Anyway, time to get back to my weird little coding exercises, I guess, to see if any of them actually turns into a game. You never know, could happen. See you next time, nerds.